BBC4's A Night of Numbers begins now with a short film exploring the Ethiopian system of multiplication, a bizarre system that ignores some numbers and dismisses others as unlucky.
Could you imagine a world without fractions? A world where you could throw away your times tables? Well, there has been such a world here in Ethiopia, where for thousands of years merchants used a strange yet very sophisticated system of multiplication to calculate the price of goods at markets throughout the Horn of Africa and the Middle East. Today, the price of Ethiopian coffee is calculated on cash registers. But where we in the West rely on modern technology, thousands of years ago, traders made their calculations with pebbles. All they needed to know is how to halve a number and how to double it. To Western eyes, the Ethiopian system is so strange that it seems more like a magic trick. To multiply 11 by 15, put the numbers into 2 columns. Keep halving the number on the left, ignoring all fractions. 11 becomes 5, becomes 2, until you reach 1. In the other column, you double. 15 becomes 30, becomes 60, becomes 120. Whenever an even number appears in the halving column, ignore the row. Group the remaining beans in the doubling column together and count. You get 165, the perfect answer. It seems unbelievable that a system can ignore fractions, even throw away parts of the calculation and still come up with the right answer. But it works every time. Take another example. When we multiply 31 by 25 using long multiplication, we multiply 31 first by 5 and then by 20 and add the results together. In Ethiopia, instead of multiplying by 5 and 20, they were effectively multiplying by 1, 8 and 16, just a different way to arrive at the number 25. By doubling a number, you're just multiplying by powers of 2. In our right-hand column, the number 31 has been multiplied by 1, then 2, then 4, then 8, and finally 16. But all that we need are the numbers that make up 25, that is the 1, the 8 and the 16. And here's the clever bit. By crossing out the even numbers on the left, you're always left with the correct powers of 2 on the right. In this case, the 2 and the 4 disappear, leaving 1, 8 and 16. By breaking the multiplication into powers of 2, the calculation has been converted into base 2 arithmetic. Once the sum has been broken down, all that remains is a simple addition. It's a system that seems completely foreign to Western eyes, but in fact we use it thousands of times a day because it's this system that powers today's computers.
So there are 3 ways in which this is real. Secondly, it's breaking multiplication down into a series of addition. And thirdly, it's breaking everything down into very simple steps.
Making calculations as simple as possible was all the inventors of the Ethiopian method wanted to do. The solution they came up with is central to the way we live today. The ways they perform their calculations are almost exactly the same as the working methods of a computer. Amazingly, it seems that centuries before the invention of computers, Ethiopian traders cracked the code that lies behind the modern age. To learn more about numbers, go to the Open University's website at open2.net.